Beneath the surface of rivers that seem calm, under stones that never move, and within the soft silence of muddy freshwater beds lives a fish that most humans never notice, yet ecosystems quietly depend on. The loach is not a creature of spectacle. It does not leap, roar, glow, or threaten. Its power is older, subtler, and far more patient. It survives by understanding the unseen rules of water, sediment, oxygen, and time. Loaches belong to a lineage of freshwater fish whose evolutionary roots stretch back millions of years, shaped not by open water speed or predatory dominance, but by adaptation to constraint. Where visibility is low, where oxygen fluctuates, where seasonal droughts and floods constantly rewrite the map, loaches learn to endure. Evolution did not give them sharp teeth or brilliant colors. Instead, it refined their senses, their bodies, and their behavior until they became masters of the bottom world. The body of a loach immediately reveals its ecological purpose. Long, slender, flexible, often eel-like, it is designed not for straight-line speed but for maneuverability in tight spaces. Stones, roots, submerged debris, compacted mud, these are not obstacles but shelter. The loach does not fight the environment, it slips into it. Its scales are small or reduced, sometimes nearly absent, allowing the fish to squeeze through narrow crevices without injury. The skin is often coated in a thick layer of mucus, reducing friction and protecting against abrasion and infection in abrasive substrates. One of the most defining features of loaches is the presence of barbels, short, whisker-like sensory organs around the mouth. These are not decorative. They are precision instruments, packed with taste buds and tactile senses. In water where visibility may be near zero, barbels become eyes, fingers, and nose combined. With them, a loach reads the texture of the riverbed, detects chemical traces of food, and distinguishes edible matter from sediment. Every movement of the barbel is a question asked of the environment, and every vibration in the water is an answer. Respiration, too, tells the story of survival under pressure. Many loach species inhabit waters where oxygen levels can drop dangerously low, especially during warm seasons or droughts. In response, some loaches evolved the ability to supplement gill breathing by gulping air at the surface and absorbing oxygen through specialized sections of the digestive tract. This adaptation allows them to survive conditions that would suffocate other fish. In extreme cases, loaches can persist in stagnant pools, slow-moving streams, or even temporarily buried in damp substrate when water levels recede. Behaviorally, loaches are creatures of rhythm rather than urgency. They spend much of their time resting partially buried in sand or mud, with only their eyes and barbels exposed. This posture is not passive. It is a strategic stillness. From here, the loach monitors the environment, conserving energy while remaining alert to subtle changes, pressure shifts, vibrations, chemical signals. When food becomes available, movement is precise and efficient, never wasteful. Feeding behavior reflects this same economy. Loaches are generally omnivorous, but their diet is shaped by availability rather than preference. Insect larvae, small crustaceans, worms, detritus, algae, organic debris, nothing is wasted. The loach is an ecological recycler, processing material that larger or more selective species ignore. By doing so, it plays a quiet but crucial role in nutrient cycling within freshwater systems. What sinks to the bottom does not stay unused for long where loaches live. Socially, loaches occupy an interesting middle ground. They are not solitary in the strict sense, yet they are not tightly schooling fish either. Many species exhibit loose social groupings, especially in environments where shelter is limited or food resources are patchy. These aggregations are not based on hierarchy or dominance but on mutual tolerance. There is safety in numbers, but no need for constant interaction. Each loach maintains its own micro-space, retreating when necessary, coexisting without conflict. Communication among loaches is subtle and largely invisible to humans. Body posture, slight color shifts, rapid movements of fins or barbels, and even sound play roles. Some loach species are capable of producing clicking or grunting noises by grinding specialized bones in their throat. These sounds may serve as warnings, stress signals, or social cues, especially in murky environments where visual communication is limited. In the underwater darkness, sound travels farther than sight. Habitat selection is where loaches truly define themselves. They are not random bottom dwellers. Each species shows preference for specific substrates, flow rates, and water chemistry. Some favor fast-flowing streams with rocky beds, anchoring themselves between stones to resist current. Others thrive in slow rivers, floodplains, rice paddies, and wetlands where sediment is soft and organic matter abundant. A few species have adapted to seasonal environments where water may disappear entirely for part of the year, surviving buried in moist soil until rains return. This ability to endure environmental instability has allowed loaches to spread across vast regions, particularly in Europe and Asia, where freshwater systems are diverse and dynamic. Over time, isolation between river basins and watersheds led to the emergence of many distinct species, each finely tuned to its local conditions. Some are widespread and resilient. Others are endemic, existing only in a single river or valley, making them vulnerable to disruption. Human activity, however, has begun to challenge even the loach's ancient resilience. Pollution, river regulation, dam construction, habitat fragmentation, and the draining of wetlands all alter the delicate balance loaches rely on. Because they live at the bottom, loaches are often among the first species to be affected by sediment contamination and chemical runoff. Heavy metals, pesticides, and microplastics accumulate where they feed and shelter, turning their ecological niche into a trap. Despite this, loaches rarely attract conservation attention. They are not large, not commercially valuable in most regions, and not charismatic by conventional standards. Yet the decline signals deeper problems within freshwater ecosystems. When loaches disappear, it often means the riverbed itself is no longer alive. Sediment becomes sterile, invertebrates vanish, and nutrient cycles break down. The loss is quiet, but the consequences ripple outward. In some cultures, loaches have long been recognized for their hardiness and adaptability. They appear in folklore, traditional medicine, and even cuisine, valued for their ability to survive transport and storage where other fish would perish. In modern aquaculture and the aquarium trade, certain loach species are appreciated for their behavior and ecological function, particularly their role in controlling pest organisms. Yet this visibility is limited, and many species remain known only to scientists and local communities. The loach does not dominate its environment. It integrates with it. Its story is not one of conquest but of coexistence. Every aspect of its biology, from the shape of its body to the sensitivity of its barbels, from its breathing strategies to its feeding habits, reflects a philosophy of survival based on flexibility, patience, and attention to detail. In a world that rewards speed and aggression, the loach proves that endurance can be just as powerful. And this is only the beginning. Beneath this calm exterior lies a deeper evolutionary narrative, complex reproductive strategies, and a fragile relationship with the future of freshwater itself. Loaches did not emerge as a single, uniform form. Their evolutionary story is one of divergence shaped by isolation, water chemistry, and geological time. As rivers shifted, mountains rose, and ice ages rewrote drainage systems, loach populations became separated, sometimes by only a few kilometers of dry land, sometimes by entire mountain ranges. In those separations, evolution worked patiently. Bodies shortened or elongated, barbels multiplied or reduced, coloration faded into camouflage or sharpened into contrast. Each variation was an answer to a specific environmental question. Some loaches evolved flattened bodies, hugging the substrate to resist strong currents. Others became cylindrical and burrowing, able to disappear into sediment within seconds. These forms are not random. They are precise responses to flow rate, substrate density, and predation pressure. In fast-flowing streams, drag means death. In still waters, visibility means vulnerability. The loach learned to negotiate both by changing shape rather than strategy. Reproduction among loaches reflects their sensitivity to environmental timing. Most species do not spawn arbitrarily. They wait. Seasonal cues such as rising water levels, temperature shifts, and changes in barometric pressure signal that conditions are right. Flooded areas provide abundant food and shelter for larvae, reducing predation and increasing survival rates. When the moment arrives, loaches migrate short distances, sometimes only a few meters, sometimes into newly flooded plains, to release eggs that drift, settle, or adhere depending on species. Eggs are typically small, numerous, and unguarded. This is not neglect, it is mathematics. In unpredictable environments, survival favors quantity over protection. Larvae hatch quickly, often within days, entering a world where speed of development matters more than size. Growth is rapid at first, fueled by abundant microorganisms and organic matter stirred up by floods. As waters recede, juveniles retreat with them, settling into the benthic lifestyle that will define their adult existence. Sensory biology is where loaches cross from ordinary fish into something almost uncanny. Many species are extraordinarily sensitive to pressure changes in the water. Long before storms arrive, loaches alter their behavior, becoming restless, surfacing more frequently, or changing position within the substrate. This sensitivity likely evolved as an early warning system, allowing them to anticipate floods, low oxygen events, or sudden temperature shifts. To a loach, weather is not something that happens above the water. It is felt directly through the body. The lateral line system, a network of sensory organs running along the sides of the fish, is highly developed. It detects vibrations and microcurrents created by moving organisms. A passing insect larva, a burrowing worm, even the slow approach of a predator sends ripples through the water that the loach can interpret with astonishing precision. Combined with chemical sensing through barbels, this creates a multi-layered perception of the environment that functions even in complete darkness. Predation pressure has shaped loach behavior as much as habitat has. Birds, larger fish, reptiles, and mammals all prey on loaches when given the opportunity. Yet loaches are rarely caught in open water. Their first defense is invisibility. Color patterns mimic gravel, sand, or leaf litter. Many species can rapidly change shade, darkening or lightening to match the substrate. Their second defense is burial. A sudden flick of the body in the loach vanishes beneath the sediment, leaving no trace but a faint cloud that dissipates within seconds. If capture occurs, some loaches employ last resort tactics. Sudden bursts of movement, spine erection in certain species, or the release of slippery mucus can make handling difficult for predators. These defenses do not guarantee survival, but they increase the odds just enough to matter over evolutionary time. Survival for a loach has never been about certainty, only probability. Within the ecosystem, loaches occupy a role that is both functional and stabilizing. By feeding on benthic invertebrates and detritus, they regulate populations that might otherwise explode or decay unchecked. Their constant movement through sediment aerates the substrate, preventing compaction and promoting microbial activity. In this way, loaches act as engineers of the riverbed, shaping the environment in subtle but continuous ways. Remove the loach, and the system does not collapse instantly. Instead, it degrades quietly. Organic matter accumulates. Oxygen levels in sediment drop. Invertebrate communities shift. These changes may go unnoticed for years, until larger, more visible species begin to decline. By then, the warning signs were already present, written in the absence of a fish most people never see. Human perception struggles with creatures like loaches because they do not perform. They do not announce their importance. Their lives unfold beneath the threshold of casual observation. Yet this invisibility is precisely what makes them reliable indicators of environmental health. Where loaches thrive, freshwater systems are usually still functioning at a fundamental level. Where they vanish, something essential has already gone wrong. As climate patterns become more erratic, the future of loaches enters uncertain territory. Their adaptability has limits. Extreme temperature swings, prolonged droughts, and chemical pollution push beyond the conditions they evolved to endure. Some species may adapt again. Others will not. Evolution is powerful, but it is not fast. Still, the loach endures, as it has for millions of years, by reading the water, listening to the sediment, and responding not with force, but with precision. Its survival strategy is not loud. It is exact. As the modern world reshapes freshwater systems at an unprecedented pace, the loach finds itself navigating a landscape far more volatile than the one that shaped its evolution. Climate change does not arrive as a single catastrophe in the loach's world. It arrives as instability. Longer dry seasons lower water levels and reduce oxygen availability. Sudden floods scour riverbeds, removing the fine sediments loaches rely on for shelter. Rising temperatures accelerate metabolic demand while simultaneously reducing dissolved oxygen, creating a physiological contradiction that no organism can ignore. For a species adapted to variability, this might seem manageable, but the scale and speed of these changes matter. Evolution equipped loaches to respond to seasonal rhythms, not constant disruption. When droughts persist beyond historical norms, the damp refuges loaches use to survive dry periods disappear entirely. When floods become too violent, eggs and larvae are swept into unsuitable habitats, breaking reproductive cycles that depend on precision timing. Human modification of rivers compounds these pressures. Dams alter flow regimes, flattening natural flood pulses that once triggered spawning. Channelization removes the complex mosaic of substrates, gravel, sand, leaf litter, that loaches require. Agricultural runoff introduces chemicals that settle directly into the benthic zone, where loaches feed and breathe. Because they live at the interface between water and sediment, loaches experience pollution not as a diluted exposure, but as a concentrated one. Urbanization adds another layer of stress. Impermeable surfaces increase runoff velocity, carrying heat, oil residues, and heavy metals into streams. Noise and vibration from infrastructure interfere with the sensory cues loaches use to interpret their environment. Even artificial light, penetrating shallow waters at night, can disrupt behavioral rhythms that evolved under darkness. Yet loaches persist in places where more conspicuous species fail. Their tolerance for low oxygen and poor visibility allows them to occupy marginal habitats others abandon. This resilience, however, creates a dangerous illusion. Rivers may appear biologically active because loaches are still present, masking deeper degradation. When loaches finally disappear, recovery becomes far more difficult because the benthic foundation of the ecosystem has already collapsed. In scientific research, loaches have become increasingly important as indicator species. Their presence, abundance, and behavior provide insight into sediment quality, oxygen dynamics, and long-term ecological stability. Subtle changes in loach populations often precede visible ecosystem decline. For researchers, this makes them invaluable. For conservation, it makes them urgent. Culturally, loaches occupy a curious position. In some regions, they are part of traditional diets, valued for their ability to survive transport and storage. In others, they appear in folklore as symbols of persistence and adaptability, creatures that endure where conditions seem impossible. These narratives reflect an intuitive understanding of the Loach's biology long before scientific frameworks existed. In the aquarium trade, certain Loach species have gained popularity for their behavior and utility. Their constant interaction with the substrate, their responsiveness to environmental changes, and their role in controlling invertebrate populations make them appealing. However, this demand introduces risks. Wild collection, when poorly regulated, can devastate localized populations, especially endemic species with limited ranges. Captive breeding has alleviated some pressure, but not all species reproduce readily outside the natural conditions. The contrast between captive and wild loaches reveals much about their needs. In controlled environments, loaches still seek shelter, still burrow, still respond to pressure changes and water chemistry. Remove these elements, and stress manifests quickly: reduced activity, suppressed immunity, shortened lifespan. Even under human care, the loach insists on ecological authenticity. What emerges from this is a broader lesson. The loach is not simply a fish adapted to harsh conditions. It is a living archive of freshwater history. Its body records the flow regimes of ancient rivers. Its behavior encodes seasonal cycles that once governed entire landscapes. When those patterns disappear, the loach does not merely lose habitat. It loses context. Conservation of loaches, therefore, is not about preserving a single species. It is about preserving processes, natural flooding, sediment movement, oxygen exchange, that sustain freshwater life as a whole. Protecting loaches means protecting the invisible mechanics of rivers, the slow interactions that rarely make headlines but determine long-term viability. As pressures mount, some loach species will adapt, shifting ranges, altering behavior, exploiting new refuges. Others will not. Their loss will not be dramatic. There will be no sudden silence, no visible catastrophe. Just an absence at the bottom, where something essential used to move. And in that absence, the river will begin to forget how to function. The true legacy of the loach is not written in size, beauty, or dominance, but in continuity. While rivers have shifted, climates have oscillated, and entire faunas have risen and vanished, loaches have remained, adapting quietly, persisting without spectacle. Their survival is not an accident. It is the result of an evolutionary philosophy built around efficiency rather than excess, awareness rather than aggression. In ecological terms, loaches represent a stabilizing force. They occupy the thin boundary between living water and living sediment, a zone where chemistry, biology, and physics intersect. By constantly moving through this space, feeding, burrowing, and respiring, they maintain conditions that allow other organisms to exist. Microbes thrive where loaches aerate sediment. Invertebrates balance where loaches feed selectively. Nutrients circulate rather than stagnate. These processes are slow, cumulative, and largely invisible, yet they define the health of freshwater systems over decades. From a future perspective, loaches may become even more important than they are today. As freshwater habitats fragment and degrade, species capable of tolerating fluctuation will shape what remains. The loach's sensitivity to pressure, chemistry, and oxygen makes it an early responder to change. It will move, adapt, or decline before larger species react. In this way, loaches act as biological forecasts, signaling shifts long before human instruments detect them. Yet this same sensitivity makes them vulnerable. Adaptation has limits. There is a threshold beyond which flexibility becomes exhaustion. Rivers that no longer flood, sediments saturated with toxins, waters warm beyond historical extremes, these are not challenges evolution prepared loaches to face all at once. Survival requires time, and the modern world is compressing ecological time into decades instead of millennia. The disappearance of loaches would not be dramatic. No headlines would announce it. But the consequences would unfold slowly and relentlessly. Riverbeds would compact, oxygen would decline, invertebrate communities would skew toward dominance rather than balance. Fish that depend on clean, structured substrates would struggle to reproduce. Step by step, the system would simplify, becoming less resilient, less productive, less alive. To understand the loach is to understand a broader truth about nature. Not all keystone species stand at the top of the food web. Some work beneath it, out of sight, shaping the foundation upon which everything else depends. The loach is one of these. It does not command attention. It earns significance. In a human-centered view of the natural world, creatures like loaches are easy to overlook. They do not inspire fear or awe. They do not symbolize power. But endurance is its own form of strength. Precision is its own form of intelligence. The loach embodies both. As rivers face an uncertain future, the presence or absence of loaches will quietly reveal what has been lost and what still remains possible. Where loaches continue to move beneath stones and sediment, there is still memory in the water. There is still structure, there is still time, and where they are gone, the river has already begun to forget itself.